Factor first. Can't factor the top, but the bottom factors is the difference of squares, x plus 5, x minus 5. Are non-permissible values, x can't equal minus 5, and x can't equal 5. Will those be poles or vertical asymptotes? Do they cancel out? They don't cancel out. Vertical asymptote at x equals negative 5 and x equals positive 5. Next, which group is this? Horizontal asymptote or oblique asymptote? Horizontal asymptote. It's group 2, where the degree is squared on the top, degree is squared on the bottom. So we look at the biggest degrees and look at their coefficients, negative 2 over 1. So we will have a horizontal asymptote at y equals negative 2. We can start drawing this. We got to go like 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Uh-oh. Y equals negative 2, x equals negative 5, and x equals 5. Y-intercept is always the easiest. I go back to my original equation. If you plug in 0, you get 0. Interesting. Next, x-intercepts. What makes the top of your fraction equal 0? 0. It's actually the same point. Oh. And it feels like we don't have very much information right now. If we look, our asymptotes gave us 3 sections. In section 1, we have no points. So let's find a point in section 1. Let's do negative 6. If I go to my original equation, negative 6 squared is 36, times the negative 2 will give me negative 72 on the top. Wow, what did I just do? Okay. Whoa. That was scary. If I plug in a negative 6 on the bottom, I will get 36 minus 25. I will get 11. This doesn't seem like a very nice point, but it's nice enough for me. Negative 72 over 11. If you estimated that, negative 6 point something, agree? It's going to be below the y equals negative 2. It's going to be down here somewhere. I can label negative 6, comma, negative 72 over 11. This asymptote will keep going. Is that enough in that section? Yes, it has to go towards the asymptote. In section 3, can you see that this is actually easy mental math to put in positive 6? Because everything was squared, can you see that we will get negative 72 over 11 again? So that's nice. And plug that point in over here, 6 comma negative 72 over 11, and that's enough for this section. Now, the middle section. Can graphs go through horizontal asymptotes in the middle? Yes. So we really don't know what's happening in the middle. You might be like, oh, You might be tempted to just say, let's go up in both directions. And that might be right, because you didn't want to go through the asymptote, but graphs can go through horizontal asymptotes in the middle. So we do need nice points here in the middle as well. So what you could do is you could go near your asymptote. Let's go at 4 and see what happens. If you plug in 4, I'll go back to my original equation. 4 squared is 16. 16 times negative 2, I would get negative 32 over, and 16 minus 25, negative 9. Agreed? If you plugged in 4. A negative over a negative is positive, so I'm going to get 32 over 9. It's going to be 3 point something. Plug that in. 4 comma 32 over 9. This section has to go up. Can you see by symmetry, if you plugged in negative 4, since it's squared, it would also have to go up. Does it make sense that this x-intercept is a bounce? Does it have a multiplicity of 2? It does. You see how x equals 0 has a multiplicity of 2 in the numerator there? And it bounces off of that as a result. What we didn't know is it could have bounced down in both directions. That's possible. Some of you don't like this, like the ambiguities, right? So whenever something is a little bit unclear or unclear, ambiguous. Ambiguity and ambiguous. That seems like English screwed up something. I should have made that clear. Anyways, whenever it is a little bit unclear, find another nice point, and it should clear it up. Okay? Sometimes it's unclear because we make mistakes. If you find a nice point and you screw up your mental math, things get messy. So that can sometimes be a problem. Take your time on the easy part, which is plugging in the numbers for the mental math, because screwing it up can really screw you up and make your graph all in the wrong place. Okay, questions for this one? Number 4.